Okay, so this is the problem that we're going to look at is how it's not in China, it's urban rural inequality. In other places, it's anything. It's human capital inequality, right? It may be race inequality. It may be north and south inequality. It could be, but in China, it's rural urban inequality, and that how it actually when countries get to middle income, and China's just middle income now, um, how that keeps them from going up. So, um, you know, I'm from the United States, and the United States and China now have this this sort of really sort of push you pull me relationship going, and it's in the United States is saying, you know, we need to keep going because so China doesn't surpass us. What I think is the biggest problem China faces, maybe that no one understands, is that they may collapse before they go further. Maybe not for sure. So the problem is if you guys watch TV, this is the China you see. And I don't care if it's China. I don't care if it's Russia. This is Moscow. I don't care if it's Brazil. This is Sao Paulo and Rio de Janeiro, right? But what you don't see is the other side of these countries, okay? And this is a book that I recently have written, and it's about inequality, and the problem of inequality is countries, especially as countries get to middle income, okay? And what I like to say is going from poor to middle income, it's not a problem. When you get to middle income and try to get to high income, it becomes a problem, okay? And I've done lots and lots of field work. You've met Albert Park. Albert was my first PhD student 32 years ago, okay? He's done very well with his life, but that he's part of this same thing. We go to the field and try to figure out the data, right? This is me going to the field in 1988. Boy, was I young then. And here's me in the field today. I mean, I want to get to the field, and it's because I go there that I've discovered that this is a huge, huge problem. So how does the inequality, the lower half of human capital in China, how does it affect its rise? Okay, I think this is a really, really important graph, very important graph, okay? Here's income. The horizontal axis is income 70 years ago in 1960, okay? And here's income today, okay? So that's what this is. And so here, these countries are poor. Congo, right? Myanmar, okay? They were poor 60 years ago. They're poor today, okay? They're poor. Here are the rich countries. So I saw somebody from the Netherlands, from England, okay? Norway, Sweden, Canada, the United States. These countries were rich 70 years ago, they're rich today, okay? They're the OECD countries, okay? So the rich person's club. I'm interested in two types of countries. I call these the graduates, okay? Look at this. So these are countries that were middle income 6 years ago, and they're high income today, okay? I want you to notice two things about these, okay? Number one, there's not very many of them, okay? Since 1960, there's only been 15 countries that have risen to high income from middle income. Now, I don't count Eastern Europe, okay? I can't remember if there's any Eastern Europeans in here. Eastern Europe was high income, then they became middle income, and now they're high income again. So that's kind of cheating, right? Okay, but these are countries that developed up till here and then became high income countries, okay? Korea and provinces, not all countries, okay? They're territories. South Korea, Israel, Ireland, Singapore, Taiwan, et cetera, et cetera, et cetera. Okay, so there's not very many. The other thing about these is the last time a country has graduated is over 20 years ago. This is hard to do, okay? The other set of countries, look at this. Most countries in the world are, they reach middle income and they collapse, and then they go and they collapse. So that they've, for 70 years, they've been in middle income, okay? And they just can't reach up. Right here, this is Brazil. Brazil almost made it, and now they're back down here again, okay? I mean, so most countries in the world, it's really hard to go from here up to here, okay? So what I want to know is what's different between these and these? And one thing I'm going to tell you about is the inequality of human capital, the inequality of education in these countries. And I'm going to show you why. But at the time of middle income, OECD says the human capital of the entire labor force has to be high. Yeah, you can have 10 or 20% of people have poor human capital, but you can't have 70%. Okay, because it's really gonna hurt you. And so let's look at this. These are the OECD countries. So these are the countries way up here, right? Rich countries, right? Netherlands, England, Norway, Sweden, the United States, Australia. In these countries, out of 10 people in their labor force, remember labor force is everyone from 20 to 60. Of 10 people in their labor force, 7 or 8 of them have been to high school or above. So in OECD says high school and above is important because when you get through high school, you learn math and computers and science and language and foreign language, okay? You have the ability to learn how to learn, okay? And so that's important, okay? Yeah, you need a few people that just, right? But you don't need that many. Look at the middle income grads, these guys, okay? When they were middle income, okay, when they were middle income, their human capital of their whole labor force was already high income. So they looked like high income countries. So 7, 8 out of 10 of their labor force, when the wages were still really low, already were high. Okay, and so they look like high income. They've prepared their labor force to become high income. Okay, but look at this, the trapped. Okay, look at these guys. Okay, Brazil, Mexico, South Africa, Colombia, Turkey. Okay, these guys, 3 out of 10, 4 out of 10. That means 6 or 7 out of 10. They haven't been to high school, so they don't know math. They don't know much science. They don't know much computers. They aren't very good in foreign language. Their language skills are poor. And that's a huge difference between these two, okay? And why is it important? Because when a country moves from middle income to high income, wages go up and the nature of work changes from low wage, low skill to high wage, high skill. And if a large share of that labor force isn't able to participate, what happens? Unemployment, the rise of informality. I'm going to talk a lot about this in just a second. High crime, social unrest. Think of Brazil, think of Mexico, think of Colombia, think of Turkey, think of South Africa. I mean, these are countries that are just rift with social problems and high crime. And guess what? Because of this, nobody wants to invest. And because there's not many people with high wage, high skill qualities, they can't find qualified workers. So companies go elsewhere in the world, and you get stagnation and polarization and et cetera, et cetera, et cetera. Okay. So this is sort of my argument about why we need to really concerned about the inequality of education. So what happens when a large share of the labor force is in the informal economy? Look, here's Argentina, Brazil, middle income. These are all middle income countries. Mexico, India, Indonesia. Look at these countries. Is half of their workers are informal sector. That means they don't have set hours. They don't have They don't have benefits. They don't have, they aren't covered by labor laws. That they, it's just they're informal, right? That they really work around there. That these are the jobs that are in the informal sector. Okay, half of the jobs in these countries, sometimes more than half of the jobs, are these types of jobs. And Professor Levy, he used to be at Harvard University. He's now at the Inter-American Development Bank. He calls this, he uses this to explain what he calls the Mexican paradox. He says, look at Mexico. They have solid macroeconomic performance, export success. They export a lot, right? They have lots of physical human capital, but no growth. Why? Productivity hasn't risen. Why? Because that informal sector is too large. It outcompetes, it pulls down, it drags down, it pushes out the formal economy. And so it's, that Mexico, is right here. And, this is the inability, when I give this talk sometimes, one of my big theses is that China has extreme inequality of human capital, and this is going to hurt China trying to now move forward. Okay, that's what I believe is possible. Not certain, but possible. And when I give this talk, people say, well, come on, China's already made it, right? When I was in grad school, just like you guys now, in the late 1980s, people thought Mexico had already made it. Okay, Mexico was high income. They were the next Taiwan. Guess what? 30 years, Mexico has not grown. And it's one of the most high crime countries in the world. So where China is today, look at China here today. Middle income. Okay, they were almost poor in 1960, but they're trying to go up there. They want to be rich, right? In the next 10 years, they want to be a high income country. When all kids don't go to college, children should be going to high school. So I think that the entire labor force of China needs to have a high school education, or most of it. It's at this, why? Because it's at this critical stage of development that the labor force gets the skills they need. Whereas China is the lowest level of human capital in middle income. Wait a minute, how can that be? They have 5 million people graduate as engineers every year. You bet. 5 million engineers and 10 million high school dropouts. Okay, inequality of education. That is what defines China. Okay, and it's not my data; it's the census data of China. And what you see is that only 30% has ever been one day to high school. Okay, and you can see China's human capital is lower than South Africa, lower than Turkey, lower than Mexico, lower than Brazil. Okay, it's the lowest in the income world, middle income world, and that it's 30% of the labor force that graduated from high school, 70% of our high school dropouts. I mean, wow, right? I mean, China has such a fabulous higher education system, and they have 70% of the people in the labor force. There's what, 900 million people in the labor force? Okay, 500 million people are high school dropouts. And this is the inequality there, is that this is, I didn't label this very, this is a 4th grade standardized test. So in 4th grade, that the World Bank, I helped them out. They went around China and they gave a standardized test, and they discovered that urban students in the 4th grade were testing at a 5th grade level. Rural students in the 4th grade was testing at a 3rd grade level. Okay, by grade 4, they were already 2 grades apart, and of course they're never going to catch up. And so the urban kids go up and become engineers and become the highest, one of the best higher education systems in the world, while the rural students, there's just massive amounts of people that are high school dropouts or below. Okay, so that's the problem. Okay, that's the problem we're going to be. Okay, but before I go here, just let me remind you what I've done so far is I say, sort of, this is the problem. Look, when you're studying your own country, you have many problems. And, I want you to identify that. That's what we do as social scientists, right? We identify problems. What my group does, what economists are, increasingly doing, we're not only identifying problems, we're then trying to figure out what works. And what we're going to be trying to teach you for the next couple days, or Monday and tonight, I guess it's Monday and Thursday for you, it's Sunday and Wednesday for Dr. Wong and I, is some methods for trying to determine what can work and what doesn't work in trying to solve these problems, okay? So before I go on, are there any questions? So all I've done so far is just like tell you what the problem is, right? You guys okay with that? Okay, so here we go. If we were going to do an entire course here, I'm going to make sure this is the right one. What Wanhua and I are going to do is we're not going to do 4 lectures. We're going to do 2 lectures. I just did the problem, and I'm going to introduce RCTs to you today, about how we use RCTs to solve problems, to identify what works and what doesn't work, okay? And then Juan, over the next couple of days, are gonna, on Thursday, your time, is gonna look at designing RCTs, some hypotheses testing, and really the econometrics of solving these, okay? And what we're going to do is we're going to look at, what is impact evaluation. We're going to look at some notations and everything. And really, we're going to look at why randomize, right? Why should we, do this? I think that we'll really go through this. And the goal, what we want to do is to measure the impact of a program, of an investment, of a new project, okay? And to see, does it work or not, right? And we'll talk a little about what the program is. We're going to certainly talk about what the impact is. Basically, what we're going to do is a program is an investment. Okay, well, what's a program, right? So here we go. What's a program? What's an investment? What's a way to solve a problem, right? We have a problem. We don't produce enough food because we don't have enough water. Does a treadle pump work? Okay, we have a problem that babies are dying. Babies are dying because moms are having babies at home. They're premature and they die because they don't have the right care. They're too far from the hospital. Do sleeping bag incubators work? Okay. Does mobile phones help solve marketing problems in developing countries? Does computer assisted learning help improve grades? Okay, that kind of thing. Okay, so in China, where I work, they have huge investments. Okay, they raised teacher salaries. They eliminated tuition for high school. They implemented a huge health insurance policy. They have a financial crisis stimulus package, okay, during COVID, okay? They threw out, I mean, hundreds of billions of dollars. Did any of these work? Do these work? This is around the world. Here's in China. Do these work? Guess what? Nobody knows. China has spent billions and billions and billions of dollars on their health insurance program, and people don't even know if it works or not, or who it works for, right? Or why it works, or why it doesn't work, okay? And those are the types of things. It's because they didn't take the time to evaluate it, okay? And this is what a fundamental thing that we want to look at. So here we go. There's many ideas and many policies, many programs, many investments. We want to answer the question, do they work? Does the primary, if we give out cell phones to increase marketing, do people earn more money from their cell? If we pass out, these incubator bags, okay, so when moms have premature children, they put their premature child in there, they bundle them up, they keep them warm, and then 2 days later they get to the hospital and the baby, do more babies die or less babies die? Okay, that's the primary outcome. But we don't only want to know if they work or not, we want to know why they work or why they don't work. Okay, if not, why not? Okay, and for whom they work. Many, many, many times programs work for, work for the people that live next to the roads, but not people who don't live next to the roads. They work for people who are low income, but they don't work for people who are high income, et cetera, et cetera, et cetera. Okay, and so they work for boys, they don't work for girls, or something like that. So these are the kinds of questions that we want to decide, because my group wants to solve the education problem. So we're going to roll out a bunch of education programs, policies, investments, and we want to know, do they work? Why do they work? Why don't they work if they don't? And for whom they work and who they don't. And so we can then twist them and then try to do it again. Okay. Let me give you an example. I'm going to give you an example first. And here's the example. Okay. So, if we give multivitamins to children in school, okay. So, this is just a little vitamin, 10 cents, costs 10 cents a vitamin. If we give that vitamin to supplement iron, okay, our test score is going to go up. Remember we saw test scores, right? Test scores were really set. So can we narrow that gap if we make the kids more nourished? Okay, and we saw this already, right? Huge difference, okay, in life. So can we collapse this gap here? If we make kids more healthy. Okay. Okay. There's many reasons why this is so huge. I can't get it's on the other one. Do you remember where those lines were? This is in 2005. This was a survey we did in 2005. In 2015, these lines are here. Okay. The lines are even further. But when these lines were this far apart, okay, that many people went out and said, school's too expensive. It's because they have poor teachers. It's because teachers aren't getting paid. It's because their facilities are so bad. Okay. It's because tuition is too high. Guess what? China got rid of tuition, provide financial aid for high school and above, paid teachers from the central government. They built new schools, beautiful, beautiful, beautiful new schools. And guess what? That got wider. Oh, wow. How come it got wider, right? So by 2015, it got wider. So rural kids fell further behind, even though the government did all these things. Okay. So one thing our group thought about was, maybe it's not the school, maybe it's the kids. Maybe the kids are unhealthy. And then, if we took an unhealthy kid and put him into the best school in China or the best school in America, he's unhealthy and he may not learn because of his health. And one health problem that we thought might be a problem, it's a problem in many parts of the world, anemia. So this is iron deficiencies. And we knew iron deficiencies affect school performance and attendance and IQ and health and behavior. Okay, there's many, many, many papers that have been written on it. Okay, and we did our first survey in 2008, and look what we found: 40% of the kids in these rural schools were anemic. Okay, and that their brains just didn't move fast enough. Okay, So we said, hey, let's go to all these different countries. So this is called Shanxi province. Shanxi province is about the size of England. Okay, two Netherlands. Okay, it's three Swedens. Okay, it's a big province. We went to counties over there, and we we found out that 39% of the kids in these randomly selected places were anemic. Okay, and then we went to another province, and 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 to another province. And over these 3 years, we had 20,000 people, and guess what? We found that 1/3 of them were anemic. I mean, this is a problem that was all over rural China at that time. Okay, 1/3 of students in poor rural areas have anemia. 20 million kids. Now, no wonder this happens, right? They're sick. Okay, so let's figure out, if we give them a vitamin, will anemia go down? If anemia goes down, do test scores go up, right? I mean, do they learn more, right? And that's what we want to do. So what's an impact? Okay, so here it is. Time, test scores, they're going up a little, right? Test scores, and then we give kids supplements. Look at their grades go. Is that because of tests? Is that because of the vitamin? I mean, but look at it, was already going up, but now it goes up fast. Well, remember, all these other things were happening too. Remember? Oops, sorry. All these other things are happening too. So is that due to the anemia or not? So what we really want to do, okay, what we really want to do is here's a kid, here's a test, and then at this year we give them a vitamin, and then 2 years, 2 years we find out what their test scores go. Okay, after 2 years, what we really want to do is we want to take time, and we want time to go backwards, and then we want to get the exact same kid and don't give him a vitamin and see what his grades are. Wouldn't that be great? Okay, so we're gonna move back in time and then let time go forward again. We're going to compare the impact of the program, of the investment, versus a counterfactual. Okay, that's what this is. The children that didn't get a vitamin, there's the children that got a vitamin, and that's an impact. Okay, that's what we want to do. Okay, can we do that? Can we do it? Yay! No, unfortunately, an impact is a comparison between the outcome, the test scores, after the program started, and the outcome at the same time if the program hadn't happened. Okay, that's an impact. That's our counterfactual. Okay, it's the test scores of the same children if they had got vitamins and they didn't get vitamins. Unfortunately, we can't do that. Okay, that's the most basic problem of impact evaluation, right? Is we can't observe a real counterfactual, because for every single individual at a particular time, either children got the vitamins or they didn't. Okay, some children got the vitamins, some didn't. Some went to college, some got health insurance, some didn't. Some got the mobile phones and some didn't, right? And then we say, hey, did the women who get the mobile phones, did their income go up, right? Did the person that get the health insurance, we gave the health insurance to these 4 counties and we didn't give it to these 4 counties, and their health got, was it because of the health insurance? Or is it because these 4 counties had better hospitals and they were getting their people better? Okay, so that's the problem, is we can't find a counterfactual. Okay, we need the counterfactual to be able to measure impact. Okay, we need the counterfactual to measure impact, but we can't observe it. So what do? Here's what we do. We need to mimic, we need to pretend like we have a counterfactual. And there's two ways to do it. One, find a group of individuals that are like the counterfactual. Okay. So we're going to go find some twins, we're going to find some twins. Okay. And we're going to give the twin one vitamin, and we're not going to give the other twin the vitamin. Okay. Or let's go to these two schools and they both look really poor, and let's give all the kids in this school vitamins and all the kids in this school no vitamins. Okay. So, that's like find a group of individuals. The other way to do it is to make a group of individuals that are really a lot like a counterfactual. Okay. So one is go find them. They're already out there. The other is make them. You do it yourself. Okay. And, oops. Okay. Okay. We need to try to mimic the counterfactual, to find a group of individuals that are like a counterfactual and make a group of individuals that okay. This right here is the same as that up there. I got these things mixed up. Okay. And what I want you to look at here is to go find a group of individuals that are like the counterfactual. This is called quasi-experiment methods. You guys, I mean, if you've been in economics, this is what you know, right? IVs, difference in differences, fixed effects, matching, synthetic control, decomposition, okay? You find a group of individuals that are, maybe the individuals is the individuals before, individuals after. Maybe it's, we're going to find 1,000 individuals here and 1,000 individuals here. And these guys took vitamins and these guys didn't. Of these 1,000 individuals, we're going to find 300 of them look exactly like 300 over here, right? And so we're going to match them together, okay? And then we're going to compare. Did the vitamins go up, okay? That's finding a group. That's quasi-experimental. If we're going to make a group, of individuals that are like a counterfactual. That's a randomized experiment, okay? And that's what we're going to study today, because if you can do it, you can't always do it, okay? And so I want to first of all say, this is really cool. These are really cool too. If you can do this, this is probably better than this, probably. But there's still a lot of problems with this. And Juan will be talking about some of the problems. I'll be talking about some of the problems. And these can really be powerful, but they can also have lots of problems, okay? So nothing is foolproof. We're going to look at this one. We're going to look at making an individual. And because groups, why is it so good? It's because when we start a randomized control trial at the baseline, the two groups are the same. It's like remember the kid, we gave him a vitamin, 2 years later we measured his thing, and then we ran back time and it's the same kid, and then we didn't give one. Well, that's what we're going to do with this one, is we're going to find two exactly identical kids, or groups of kids, and one we're going to give vitamin and they're going to go, and the other we aren't, and then that's going to be the impact, okay? Any difference later is due to the experiment or the program, because they start out, they're exactly identical. It's like the same kid, okay? That's the theory, okay? That's why we're doing it, okay? So what I'm going to do for the rest of the time, I about another half hour or so, we're going to look at what is impact evaluation, with the potential outcomes and causal model, and then why randomize. So I'm going to give you guys, everybody's going to get a copy of the PowerPoint right after. I'm going to send it to Kathy, and then she can send it out to the whole group. But the notation we're going to use is that, let's say we have N people, okay? And we're interested in evaluating the impact of a program on those people. Students in class with anemia, okay? Students, there'll be N households, N farms, N students, okay? But abstract label for the N is people, okay? Simplicity, assume the treatment is binary. They get a vitamin or not, okay? They get health insurance or not. That's going to be the easy way. Sometimes there's doses, okay? But let's just do that. And W, it denotes whether the individual received the treatment. W0, I didn't get the treatment. I didn't get the vitamin. W1 is I got the vitamin, okay? So right when we go like that, we find out that the one kid got it is W1, and the one W0 means he didn't get it. Okay. Now the outcomes are the test scores. Okay. Let variable Y represent the outcome that the treatment is supposed to have an effect. For a given person, there are two values of Y. Okay, remember, we have you give the kid a treatment and he's got the test score here, and then we roll time back and you don't give him one, he gets one here. So that the two outcomes are for any given person, there are two values of Y, okay? Value Y1 is the value of Y for the person that wasn't treated. And that's basically his test score for the kid that didn't get a vitamin. And then if we gave the kid the vitamin, it's going to be a test score of the kid if he got the vitamin. That's when he's treated. So for both YI0 and YI1 are defined for everyone. Okay, so everybody has a YI and everybody has a YI0 and everybody has a YI1. Okay, the problem is we only observe one of them. We either observe somebody's YI1 or we observe their Y0, okay? Because we can't roll ourselves back in time, okay? So, but everybody does have two Ys, okay? And what we want to estimate is this, of course, right? And the main problem is that for each person, we only observe Y1 or Y0, okay? So we've been through this, okay? So that's the notation of there. The last piece of notation is that the observed value of Y, the actual value, okay? So this is a point. The actual value that we observe for that person, okay, is denoted as YI, not 0 or 1, okay? It's a very simple relationship, okay? YI, okay, the person's test score is either YI0, he didn't get a vitamin, times Y1 minus WI. Remember, WI is 0 if he didn't get a vitamin. So if that's 0, then this is 1. So his YI is Y0. And then this WI is 0. So this is his actual Y, that if he took the vitamin, but it's times 0, so it disappears, right? Okay. So in other words, Y0 is for person I when we observe that person is Y0. If Y1, then we observe Y1, okay? So YI is our data, okay? And for some people, we see YI0, and some people we see YI1, okay? And with the RCT, we're going to know that, okay? And we're actually going to create that. Okay, so I'm not going to spend a whole bunch of time on here, but there's 3 scenarios for how W's are determined. Okay, the first one is the best one, is the experiment. Okay, WI is randomly assigned. Okay, I take the whole class here. Let me see how many people are in I can't see how many people are in class now. 40 people in class, okay? I randomly flip a coin, and if it's heads, you go and sleep at the 5-star hotel right down the street from the Hong Kong Science and Tech. And if it's tails, you got to pitch a tent and sleep outside, okay? And so 20 of you are going to get a 5-star treatment, and 20 of you are going to have to sleep outdoors. And at the end of the class, I want to see how you do on a final exam. Okay. So we're going to do this experiment. As you may guess, WI is completely orthogonal, right? It's that YI1 and YI0 and YI1, that they're randomly assigned. Okay. And if there's a difference between the outcome variables, it's 100% due to the assignment. Easy, done. We're done. I mean, I love these because I'm not very good at math. That's why I want to teach in the other course. And to look at the impacts from a randomized control trial is really easy. Yeah, mostly. There's lots of things that are hard. Number two, why WI isn't randomly assigned, but is conditional on some observed values of X1. Okay. So it's not, it doesn't depend on Y0 and Y1. Okay. It's independent of that. So formally, this means that, these things are getting treated, and the person who's in the treatment or is random. Okay. But it depends on your X. Okay. Okay. So think about this. It's the basic idea is once we control for X, there's no correlation between W and YI0, YI1. Let me go ahead, then I'll come back to this. Okay. In effect, for a given value of X, so an X for, remember our kids in school. So this is for boys, okay, versus girls. Okay. When boys have anemia, oh my God, they don't sit still. They poke their neighbor. They get up and run around. They get really angry because they're not caught up. And girls, when they get anemia, sometimes they try harder. Okay, so in effect, what we want to see is, we want to match. We want to compare the boys who are taking vitamins from the boys that aren't taking vitamins. Okay. And the girls who are taking vitamins, we didn't assign the vitamins. We went in. So here's 10 people. We said, who's taking vitamins? These 6 people. Who's not taking vitamins? These 4 people. Okay. Then what we want to do is we want to say, where are the boys? Here's 2 boys, compare their grades. Here's 2 girls, compare their grades. Here's the 6 that took vitamins. Okay, of the 6, these 2 boys compare their grades. These 2 girls compare their grades. These 2 boys compare their grades. Okay, and then we're going to take the average of the boys who took the vitamins from the girls who took the vitamins, the average of the girls who took the vitamins and didn't take the vitamins, and then average those 2 together, and we're going to get W isn't randomly assigned, but it's conditional on X. Okay, that's called matching. Okay, in econometrics, if you guys have had econometrics or that this is what matching does. Okay, and while this assumption is true, it's certainly that's not as strong as this. Oops, I'm sorry. This isn't as strong as this. Okay, a randomized control trial is definitely stronger than this. Sometimes you can't do a randomized control trial, so this is the next best way to do it. Okay. It's called conditional independence. Okay. An example, we made vitamins freely available to any household that would come to the clinic and pick them up. We are interested, will this lead to higher test scores? So we just put vitamins out in the lobby of our school. Okay. This is not true, right? No, this isn't true. Clearly, parents with higher education, job experience will be the ones that take advantage of the program much more than those who don't, who have lower levels of education. So since test scores of children are likely to be correlated to levels of education IQ of the parents, this isn't true. So what happens if we did a huge survey? We found hundreds of households that have the same level of education, the same IQ level, the same work experience, and then just what I talked about, boys and girls. We had hundreds of identical twins. Some of them participated and some of them didn't. Okay. Then we get, yes, conditional on X, then we have a randomized spiritual. We can check those who took vitamins versus those didn't take vitamins. If we get this for lots and lots of values of X and average them, it would give us a population estimate of the impact of offering vitamin supplements to their kids. Okay. Of course, this is the assumption that we make when we use matching. Later on in your lecture today or somewhere else, you're going to get this. It's a strong assumption. Most economic journals now don't like matching. Okay. They don't believe this. They don't believe this assumption. Okay. They just think that there's a whole bunch of things that I don't observe that are correlated with this observed that are making that get the test scores high and get vitamins high. So your test scores are high, not because you take vitamins, but because something else you don't observe that's correlated with X is high. This is always going to be a problem. Okay. So the last one is WI depends on X and Y. Oh, you're taking a vitamin, the person who takes it, the person who doesn't take it, even after conditioning on X, that whoever took this depended on, do you have high or low test scores? Okay. I don't want to go into this now. It's the same idea as I just went through, but it's even harder. So now we need to go get a natural experiment. We need an IV. We need a regression discontinuity. We need a difference in difference. So we need a natural experiment here to find two groups of people, who there was a neighborhood. Okay. There was a neighborhood right here, and everybody in this neighborhood could go to this store and buy vitamins. And everybody in this neighborhood couldn't go to that store, and their store didn't have vitamins. And they live right in the same neighborhood, but they these guys just can't get vitamins, and these guys can. So there really should be the same people. And will the test scores of the kids in these neighborhoods be higher than the ones in these neighborhoods? That's like a regression discontinuity or an instrumental variable. Okay. And I'm not going to go any further, but if you get a good regression discontinuity, or you get a good IV, a good natural experiment, you can still look at impacts. Okay. But it's hard. Okay. We're going to focus on scenario 1. Okay. Randomized control trials, where W1, do you get a vitamin or not, is totally randomly decided. Okay. And that is, we can make sure that W is completely independent of their test scores, if they took it or not. Okay. And we're going to determine W ourselves. We decide. Okay. When we do this, we're going to look at some different impacts. Okay. So we want to look at the difference between the kids who took the vitamins and the kids who didn't take the vitamins. Right. Okay. And what we're going to do is we're going to go find 500 kids, we're going to go find 1,000 kids, and we're going to randomly choose 500 and give them a vitamin, and randomly choose 500 and not give them a vitamin. Okay. And then what we're going to do is we're then going to give them a test, and the kids we give a vitamin, here's the test scores of kids we give a vitamin, here's the test scores of kids we didn't give a vitamin. That difference is going to be the impact. Okay. That's going to be called the average treatment effect. So now look at, here's 500 kids. Some of these kids had a huge impact. Some of these kids had a little impact. Other kids had a huger impact. Some kids had a negative impact, right? I mean, I don't know why. Some of these kids didn't get a vitamin. They went higher. Some went lower. Some stayed the same, okay? What we're going to do is we're going to average all the people who got a vitamin, okay, and average all the people who didn't get a vitamin, and look at that. That's the average treatment effect. That's the pure and simple impact of a program, okay, of a new program, okay? How would Y change if the whole sample were treated relative to the situation where no one was treated? Okay, that's what we're looking for. That's the average treatment effect. Now there's heterogeneity in here. Okay, so we give these vitamins to these kids, and remember the girls were already, even though they were anemic, they really worked hard. They went home and worked hard. So we give them vitamin, maybe their grades go up a little, and then we give the boys one. Now the boys did go home, but we give the boys, and all of a sudden they can focus, and their grades go way up. Okay. Now over here, there's no impact. And so the impact of girls is this much, impact of boys is this much. So the average treatment effect is this much, right? This times this if they're 50-50 boys and girls. But there's a heterogeneous, that the impact, this giving kids vitamins has a much bigger impact on boys than it does have on girls. Okay. So that's the heterogeneous effect. And we're going to be very, very interested in that. Okay. And it's just not boys and girls. It's, does it help the high performing kids, low performing kids, kids that, live with their grandparents, kids that don't. Okay. So that's the such. And the second thing. So the first thing is the average treatment effect. The second thing is head effects, heterogeneous effects. And the last one is the average treatment effect on the treated. Here's 500 kids. We choose to get vitamins. 500 kids, we choose not to get vitamins. We give them the vitamins and send them home and say, every night take those vitamins. And these kids, we don't give anything, so they don't have vitamins. Okay. Guess what? These kids, they go home. These kids go home, and some of them take the vitamins and some of them don't. Some of them take the vitamins and dump them out. Some of them take the vitamins and their mom's not looking, and they go, and they spit it out, right? Okay. And so what we really want to know is, what's the average effect of the treat on the treated? Okay. And this is the second most common parameter for researchers doing program evaluation, doing RCTs, is to estimate the average impact on the treated. Oftentimes, we'll look at an AT and there's no impact. It's positive, but there's a lot of heterogeneity. It's insignificant. It's zero. But then you look at the impact on the low performing kids. Well, they were low performing because they were anemic. But if we look at the impact on the kids that are anemic, wow, it has a big effect. Okay. And so that is, if they actually took the vitamin when they were part of the treatment group, okay, right? They were part of this group. Some took it and some didn't, but if they actually did take it, what's the impact? So this is a very important thing, and Wang will look more at that, afterwards. In words, this is the average treatment effect for those members of the sample who obtained the treatment. They were in the treatment group. They were supposed to get it, and they got it. But then there's going to be people in the treatment group that are supposed to get it, guess what, that don't get it for a variety of reasons, okay? And so intuitively, ATT is the answer to the following question: how does Y change, test scores change, when those members of the population who were supposed to be treated were actually treated, okay? I'm going to skip over selection bias. We'll work on that later. Okay, wow, lots of math there. Okay, what I'm going to do right now is I'm going to give you an example, okay? And I'm going to try to do it in about 5 minutes, and we can open it to questions. Advantages of RCT, because groups don't differ at the start of the experiment. If the difference is later, it's due to experiment program, okay? So that's what this means, okay? So they start the same, they're randomized, and any difference at the end of the project is due to that. So here's the gold standard, randomized trial, okay? This is, we're social scientists, right? Our lab scientists for, what is it, Leonardo da Vinci discovered randomized control trials 500 years ago, right? And they take a bunch of rats, they're absolutely identical, right? And they shoot something into this one, and then they don't shoot anything in this one. Maybe they shoot water into this one, right? And we see do these rats die more than these? Do these live or do these, die more? And what's the counterfactual? Okay. These guys are the counterfactual. Here's the factual. Does the drug work to save the rats? And this is the counterfactual. Okay. About 150 years ago, agricultural scientists figured randomized control trials, right? And here's a type of a seed, and here's another type of a seed. We sprayed this with insecticide, and we didn't spray that with insecticide. That this has huge yields, and this has really lots of grass, lots of leaves, and nothing else. What's the counterfactual here? This is the factual, is the one where we treated it with pesticides or whatever, and this is one we didn't treat with. So that's the counterfactual. So we're going to look at the yields from this versus the yields from that, and that's the impact. Okay, come on. I mean, we know that, right? That's what. Okay, what we are is we're social scientists, and we're going to do the same thing as this and the same thing as this, but we're going to do it in society. Okay, we're going to go to 50 schools, and we're going to randomly choose 25 of them, and in these 25 we're going to give them vitamins, and these 25 we're not, right? And we're going to get, so here are the basic steps of an RCT. Okay, this is 1, 2, 3, 4, 5, 6, 7. You do these 7, and you're going to run a really good RCT. Number 1 is the design. Okay, does giving multivitamins to children in school improve test scores? Okay, we want to know how to do that. And you know what? We don't want any kids putting the vitamin in their mouth and spitting it out. So guess what? We're going to design the survey so the teacher every day gives the kid a paper cup and a vitamin and clean water, and she watches or he watches the kid take the vitamin and swallow it. Okay? And then the kid has to go, so they see, okay, that's the design. The problem is their diet. And this was when we were working in China. They ate grain. They had really poor nutrition. Okay, so what can be done, right? We saw this before. Well, iron supplements, they don't get enough food, so let's give them a vitamin, okay, plus their diet, right? And will that lessen anemia and increase performance? And here are the 3 stages of it. There's only 3 stages: a baseline survey, randomization, the treatment, and then the evaluation survey. Okay, and our 2 main outcome variables are anemia and math scores. Okay, and our questions are here. This is our design. Okay, so we have 143. Remember this place in Shanxi? It's as big as 2 Englands. Okay, there's 143 town rural schools in these 7 counties. Okay, we're going to choose 66 of them. Okay, we're going to choose 66 schools. Okay, and we're going to look at all 4th graders in those schools, age 9 to 11. In those 66 schools, there's 4,000 students, 3,849 students. Okay, so that's going to be our control. And then we're going to go, we haven't decided which one is going to get the vitamin and not yet. We don't know yet. Okay, but we go to every one of those schools, all 3,849 people, and take their anemia test. This is a nurse that does it. And we give them a test, an exam, a TIMS test. Okay, all 4th grade students are going to take it. We then take that data, we take it back to our school, and we enter all that data into a computer, and then we randomize 33 schools and 33 schools. So the 33 schools, they look like exactly identical twins. The same number of boys and girls, same number of boys and girls here, boys and girls here, same age here, same age here. Their parents have the same level of education here. Their parents have the same level of education here. All these things have to be exactly 2 identical twins. After that, we flip a coin and say, let's give these guys vitamins and these guys don't get vitamins. Okay, these guys get vitamins. And that's what here in the treatment group, we give them vitamins. In the control group, we give them 0. Okay, and the intervention is here, right? And this is, we've already talked about that. Look at the teacher watching him take him. And in the 25 controls group, nothing. Okay, and we do that for 6 months, every day. And then on 6 months later, we go back to the schools, all 66 of them. Remember, 33 got vitamins, 33 didn't. Okay, and we give them another test. Okay, and we see how much has their math gone up. And then we give them another anemia test. How much has their anemia went down? Okay, and this is what we come up with. Okay, so here's the 66 schools. Okay, 3,849 students. And this is what we get, is you can see at baseline, 33% of the students have anemia rates. That means their hemoglobin rates are below 120 grams per liter. Wow, half the kids in these schools are there. Here's the control group, and here's all the students. And look at the difference between there. The difference between the information and control group are almost the same. In other words, that we have groups that are really similar. We actually divided this into, there's actually 99 schools, by the way. 33 of them didn't get anything. 33 of them got vitamins. 33 of them, we told the parents, hey, your kid's anemic, you should give them vitamins. Okay, so that's a third group. But I'm going to look at just at vitamins versus no vitamins. And you can see the blue is the treatment, the baseline for the control schools, and the red is the inline. And you can see over the whole time here is that their grades went up a little, their test scores went up a little. Okay, you can, this is the anemia rates. Okay, you can see from fall to spring that we didn't give them anything, but they got a little bit better. Okay, but look at here in the vitamin school, the shift to the right is much clearer. It's a little here, but it's much clearer here. So anemia rate did fall in the vitamin schools. Okay, so that's the first thing to see from there. And this is what happened. The difference in HB test values is HB went up. That means they have more iron in their blood by 3 points in the vitamin schools, by only 1 point in the control schools. And look at the information schools, same as the control schools. There's no difference. So kids, go tell your parents that you're anemic. And guess what? They never went and told them. So there was a big treatment effect. Okay. And then we're going to look at this is outcome. So this is change of test scores. Did they take the vitamin or not? Yes or no. Change of test scores. Did they take the vitamin or not? Yes or no. And we're going to add school fixed effects. Right here, county fixed effects. So within the county, okay. And then the last one is we're going to look at the change of test scores, whether they got a vitamin or not. And then we're going to control for school effects and student effects and county effects. Okay. So these are called unadjusted effects and these are called adjusted effects. The impact of the treatment is right here. Okay. And this is what we find is that it doesn't matter if you control for everything or just for this, is that you get an impact that iron goes up, anemia goes down. Okay, good. So giving kids vitamins helps. Okay, and this is the difference of that's just looking at that at a bigger level. Okay, so you can just see it better here. The other thing is, this is the test scores. Okay, so we went to the Ministry of Education and showed them this, right? And they said, oh, that's kind of boring. Okay, but then we went and said, but look at when you give them vitamins, remember that gap between rural and urban? It got smaller. It didn't go away, but it got significantly smaller. And this was especially true for kids that had anemia. So remember, we gave vitamins to every kid. The kids with we gave the kids, let's go back here, it's right here. We gave these kids vitamins and we gave these kids vitamins. So let's now look at heterogeneous effects. What happens to the test scores of the kids that were anemic versus the kids that weren't anemic, right? And we go here, and this is right here. This is the impact of the heterogeneous effects of the kids that were anemic at baseline. So it's actually bigger than for the average ones. So for the kids that weren't anemic, well, wait a minute, if they weren't anemic, why did their test scores go up some? Well, you know why? It's because for these kids who were anemic, because they couldn't focus and everything, they were always bothering their neighbors who weren't anemic, and their test scores. As soon as these guys started focusing on their lessons more, the kids who weren't anemic could focus on their lessons more. And so this was a win-win-win there. So to do an RCT, here are the things that the different steps that you design it, you get baseline data, you randomly assign it, then you verify that it looks random. You then implement the program. You then collect follow-up data and estimate the impacts and assess if they're statistically significant or not. I think that's all we're going to do tonight. It's quite near the end of time. We have 2 minutes. Wang Huan, do you want to come up and tell people what you're going to do on Wednesday?
Sure. On Wednesday, we're going to go over the design of RCTs and also the randomization, and also cover the power calculation and stress to the validity of randomized controlled experiments. So we'll get to the more kind of technical and practical part.
Okay, and so here's another question, Wang Huan. I'm going to test you. I wonder. Chen Chen asks, I wonder in what situation collecting baseline data is not necessarily in implementing an RCT.
In what situation collecting the baseline data is not necessary? I would say actually collecting baseline data is definitely necessary when you're trying to run an experiment, because what we want to make sure is the before you start randomize assign your sample to groups, the two groups are balanced.
Yeah,
we can talk more about that.
Yes, we can talk
about what
right.
that means.
What look at what happens here. Oops, here. This is our design. So what he's saying is you design it, don't collect baseline data, implement it, and then follow up. In other words, get rid of this. The problem is, let me tell you what happens, Chen Chen and everybody else, is when we collect this baseline data, okay, we then randomly assign 33 schools to get treatment and 33 schools to not. And then what we do is, remember, we compare, all of these, we compare hemoglobin levels at baseline, percentage of students, standardized math scores, percentage of boarding students, all of these, okay? We compare all of those, okay? And then if they're all exactly the same, then we implement, okay? But guess what? Is probably what, Wang Huan? Almost every time you randomly choose 33 schools and randomly choose 33 schools, and guess what? You get differences. Oh, the 33 schools that I just happened to take, their parents have a higher education than the kids that didn't, or vice versa. So what do? We re-randomize, and then re-randomize, and re-randomize until you get a sample where everything is exactly the same. Because remember, that's what's important in a randomized control trials, that you start the same. Okay. Now, if you don't, you know, you probably have a good IV, right? What's your IV? The IV is the treatment. So it's like an IV then, but you're not sure where you started. So you can do it, you know, if you're completely have no money, or maybe, you know, that you can do it and you probably get okay results, but it's much, much better to get baseline data. Would you say that, Wang?
Yeah.
Okay. Are there any other questions? I'm going to take this PowerPoint and send it over to Kathy. And then it's now Monday on Thursday morning, then Wang will continue, and she'll dive deep, like she said she's going to do, and teach you guys actually how to do this. So and let me tell you, when you get this, one of the very fun things about doing this is going out and giving vitamins to all those kids, watching their grades go up. Wow, it's so exciting. You know, let me tell you though, sometimes you go out and you give vitamins to the kids and they don't go up. It's really depressing. Okay, so
I have a question.
Yes, please.
Sorry. Yes, sorry. Like it's a trivial question actually. I mean, it's not related to the technique of measuring evaluation, but then just asking your opinion in general on the trend of applied microeconomic study. Is it like now the trend is going to more doing evaluation or exploratory or description, or what do you think about that? Because I'm still in my first year of PhD and was thinking of what to do and to narrow down my research topic as well.
Well, I think you need to certainly applied micro, using data sets that have been examined, looking at problems that can't be randomized, not doing program evaluation. Those are fantastic. I mean, you need to do those. I mean, but you know, I think of program evaluation as applied micro analysis. Okay. This is just one type of it. Okay. And so I think you need to I always say, start with the problem you're interested in. Okay. If the problem you're interested in is, how do I get Chinese kids to, you know, have their test scores rise, you know, and then go find the problem. Maybe the problem's in the literature. Hey, there's a huge number of kids that are sick. By the way, after we got done with this program, the national government of China, due to our results and some other people's work, they now have 26 million kids get a nutritious lunch every day. Okay, because of this type of stuff. Guess what we did next? We then said, oh, there's a whole bunch of kids that are sitting in class without glasses. Okay, now, and so we said, what happens if you give kids eyeglasses? Okay, but that's what our program is, because our objective is to try to reduce that inequality of education. But there's 100 questions that are interesting, Dia, that program evaluation doesn't fit, and that they're obviously valid and very important to look at. Okay.
Yeah, thank you.
Is there anyone else? You know, you can think of, we'll start with question and answer period. Maybe you go through the PowerPoint again. Why don't we start with that, Wang, when we start on our Wednesday night, their Thursday, and then maybe we can even throw some questions up there and test you guys. Okay. Okay.
Hi, Professor. I have a question.
Okay.
Could you hear me?
Is this
yes,
Annie? Yes, Annie. Yes. Okay, go ahead.
Yes. I wonder, in your control group, will you give the students some placebo medicine, which has no effect on student, but let them think they are having something just like the treatment group that you put some vitamin to them.
It's a great question. Guess what? To do an experiment, to do a data collection on any group of people, that we have to go to our internal review board at Stanford, and then we have to go in China to the internal review board of the Chinese university. Okay, and they say, is it ethical to give the control group a placebo, okay, or something like that? And guess what? For nutrition studies in the field, you can't give placebos. You can't give that. Why? Because the thing is we'd say, hey, these are iron, right? Okay. And then what the students might do is go home and tell their mom, hey, I'm getting a lot of iron today. I want to eat more ice cream. I don't need to eat meat, or, I mean, that's that. And so having the placebo might affect their behavior. Having a placebo is a great idea. It's a really, really good idea, but no ethical review board will allow it for nutrition studies. We'll often do placebos in other types of studies, or we'll do, so sometimes we'll use like computers and games to see can we give them remediation tutoring, and the control group will have them go to a study session with their teacher. Okay, and so we'll compare. It'll compare computers versus teachers, right? And so the teachers are a little bit like a placebo, but for nutrition studies, you can't do it. So I think that's a real important part of the design, thinking that through. Okay. The other thing you have to really worry about is you can't give and we never did. That's why we picked 66 schools across Shanxi province, which is like England, because we didn't want to have one class getting vitamins in the same this class getting no vitamins. Okay, because these kids might say, hey, I feel better, I'm doing better in school, and they go tell these kids, and these kids go home and tell their mom, and their mom goes buys vitamins at home and gives them at home. So you have to worry about spillover too. So and that's all part of the design. And so it's a good question.
Okay, I see. Thank you.
Going. We'll that Juan and I will work on a few questions. We'll post the questions before we start, and then see how good you guys studied the PowerPoint. Okay.